Section 9.5 deals with conic sections in polar form. All I want to talk about in this case is it's kind of special because conic sections, remember, are things like ellipses, hyperbolas, and parabolas. And in polar form, they can all be described by one equation. Okay, so the general equation for a conic section with one vertex sitting at the origin is given here. It's r, that's going to be a function of theta, is e times d over 1 plus or minus e times either cosine theta or sine theta. All right, now the fact that I have a plus or minus here means that e is strictly greater than 0 because I take care of the negative by this, okay? And e, in fact, which is strictly greater than 0, even has a name. It's called the eccentricity of the curve. So there is standard form. Once you put it in that form, you can determine what kind of conic section you've got. And in particular, if e is greater than 0, we've got a hyperbola. If e are not greater than 0, but rather greater than 1, if e is equal to 1, we have a parabola. And if e is less than 1, we have an ellipse. And remember, e is always given to be greater than 0. Okay, so bottom line, put it in this form, figure out what e is, and you can tell me which of the conic sections it is. What's important about this form? The fact that I have a 1 sitting right there. Okay, that's what we have to fix. And if you're curious about this d part, d actually has a geometric meaning as well. It's the distance from the origin to the directrix, to a directrix, right? But we're not going to concern ourselves with that this semester. I think one example might work. So let's name the curve r equals this. Okay, so r equals 4 over 3 plus 2 sine theta. Okay, I recognize it as being able to put it in standard form. What's a standard form? I need to get rid of this 3. How do I get rid of the 3? Well, I go down here and I factor the 3 out. But if I factor it out of here, I also have to factor it out of there, so I get 3 times what? 1 plus 2/3 sine theta. What can I do with this 3? And the answer is take it upstairs. So I've got 4/3 upstairs, 1 plus 2/3 sine theta downstairs. Now compare this with this up here at the very top. And you figure out that e is 2/3. What's important? 2/3 is less than 1. So if the eccentricity is less than 1, what have we got? An ellipse. All right, that's all I expect you to be able to do. Recognize when I have a conic section in polar form and tell me whether or not what kind of conic section it is, hyperbola, parabola, or ellipse. And that's all I have to say about section 9.5. Bye.